Hi friends, this is Dr. G. Srinivasa Gupta, Professor from Department of Mechanical Engineering of VIGNANA JYOTHI Institute of Engineering and Technology. As a part of Dynamics of Machinery course, today we are going to discuss a concept on effect of unbalanced reciprocating masses. We have seen already in the previous lectures what are the unbalancing reciprocating masses, especially we have taken the example of single slider crank cylinder mechanism. So the force acceleration of reciprocating mass, that is piston, we have seen that is r omega square cos theta plus cos 2 theta by n, that is L by R, n is. So the force with which piston is going to pushed is mr because of this acceleration omega square cos theta plus cos 2 theta by L by R. Okay. So this is the acceleration force. So as per D'Alembert's principle, we have inertia force opposite to this. So this inertia force leads to unbalancing mass in the direction of acting that force, opposite direction, that inertia force. So how to do the balancing of this force? That is the concept here, and whether we are able to balance it completely, or if we do partial balancing, then what is the effect of partial balancing? So we are going to discuss today. Because of unbalancing of some of the are partially balanced and partially unbalancing. So this unbalancing results three effects. These are tractive effect, swaying couple, and hammer blow. We are going to discuss these in detail, how they are going to arise. Tractive effect is a force. This is unbalanced horizontal force along the line of stroke, that is along the motion. Swaying couple is another quantity which is moment couple, which is unbalanced sideways rocking movement. And hammer blow is a force which is unbalanced vertical force on rails. It does mean it is perpendicular to the line of stroke. The vehicle is going to vibrate. So direction is concerned, tractive effort is along the line of stroke, swaying couple is perpendicular to the line of stroke, hammer blow is vertical, upward and downward motion. Coming to the unbalancing force, so if I try to balance it, what happened? Let me draw for that a slider crank mechanism again. Okay, this is the crank and connected to the connecting rod. Connecting rod other end is connected to the slider, that is piston, and piston is taking sliding motion in the cylinder, reciprocating motion, right? Okay, so then this is the pivot because line of stroke is this one. Okay, so then we have seen the inertia force because of acceleration, force due to acceleration we have seen mr omega square into cos theta plus cos 2 theta by L by R. So inertia force is, this is the direction of piston is going to push, that is the F, acceleration force. That is equivalent amount of inertia force is existing because of this reciprocating of the piston. So the magnitude what we have already mentioned is mr omega square cos theta plus cos 2 theta by L by R. L is, you know already, L is length of the connecting rod, R is crank length, theta is the initial inclination of angle theta with the line of stroke, crank angle, crank inclination with the line of stroke. So in this, these are two components, mr omega square cos theta, primary force, mr omega square cos 2 theta by L by R, secondary force. So if you try to balance it, because these forces are acting in this direction along the line of stroke, this is unbalanced force, Fi we can say, this is the magnitude. Then there are various approaches, because crank is going to rotate in circular motion, okay, crank making revolutions. Suppose we are going to try to balance, let us consider first primary force. Similar way secondary force also we can do. Okay, if we try to balance, okay, crank is rotating, it is easy to, okay, get an idea of attaching some mass which is equal to m, because crank is rotating with omega and r. So if we attach that mass which leads to centrifugal force, mr omega square cos theta, let me talk about primary force. Then what happened? This is because this gives at this position opposite to crank direction we are going to attach. So this leads to horizontal component of force mr omega square. We are attaching the mass, r is the crank radius, it is rotating omega. So centrifugal force is mr omega square. Then the horizontal component of this is mr omega square cos theta. You know that direction is, okay, opposite direction to the inertia force. So it is balanced in that direction. But it has also a component in perpendicular to the line of stroke. That is, we can write mr omega square sin theta. This is again unbalanced force. Okay, so this value, if theta becomes either 90 or 270, this becomes maximum. So this leads to hammer blow of the engine. Okay, engine will try to oscillate perpendicular to the line of stroke. That is called hammer blow, if it becomes maximum. So we come to a compromise that, because this is very effective on the engine performance, and components also may get failure. So what we need to do is, we come to a compromise that we should not, we cannot balance all the complete inertia forces. So only fraction of the forces, that fraction is at least 50 to 50%, minimum to 75%. Let us take 50%. So if we try to balance 50% only, that means we are going to use Cm mass in place of m. Then you know that unbalanced force remain in the direction of line of stroke is 1 minus c times this Fi again, omega square cos theta. If you attach the mass such that it is partially balancing, that means instead of m, Cm, 50% of mass only attached, then there will be a unbalanced force remain in the direction, okay, of line of stroke. That is 1 minus c mr omega square cos theta, because it is going to give Cm times r omega square cos theta, okay, that is balanced because this is in this direction, and remaining, because we are going to have this 50% only balanced, then remaining unbalanced is 1 minus c, okay. If you deduct total is mr omega square cos theta, so 1 minus c mr omega square cos theta is unbalanced in horizontal direction. This leads to tractive effect. So tractive effect is unbalanced inertia force reciprocating parts. If you partially trying to balance, then that acts directly along the direction of motion of the piston. Okay, so that is 1 minus c mr omega square cos theta. If you okay, see secondary also, then c times mr omega square cos theta plus cos 2 theta by n. Okay, this is the relation here, tractive effect relation which you are going to see here is, if you are trying to make it fully balanced, then that is the tractive effect as you have seen here. Okay, so partially we are going to balance, then this is the problem, right? Okay, so this Ft without attaching any balance mass, then as you know that inertia force is unbalanced mass, that is mr omega square cos theta plus cos theta by n. That leads to tractive effect. Even though we are going to attach partial balancing of this, we will try to do it, then there will be a remaining unbalanced force, or we can say unbalanced force 1 minus c times mr omega square cos theta is unbalanced force which is in the direction of line of stroke, which leads to tractive effect. Okay, so engine will move along the line of stroke to and fro like, okay, so that is the problem. Okay, then if you try to balance this partial mass, then this also leads to vertical component of force. Okay, horizontal is we are going to balance C mr omega square cos theta out of this mr omega square cos theta. Then it also gives vertical component, that is component perpendicular to the line of stroke, that is Cm r omega square sin theta. Cm r omega square sin theta, which is perpendicular to the line of stroke. This is the, okay, in single cylinder engine, okay, if it becomes maximum, then it is called hammer blow. If you use 2 cylinders, okay, inline engine it is called, and putting the cranks opposite in direction, then there is some relaxation, that this is vertical direction here, and second cylinder this is in this direction, because these two are separated by some distance. Okay, we can say some distance d. Then the force wise it is balanced. If you take inline engine 2 cylinders, this is what I am going to say is this is swaying couple. Okay, force is going to balance, but it leads to about center line. This force is creating couple, this force into d by 2. Okay, let us say this is F1, this is F2, of course, both are same, then force is balancing. Then F1 into C by 2, counterclockwise movement, about central line of this, okay, inline engine cylinders. Then F2 minus F2 into F2 into C by, this is same direction, F2 into C by 2. So what happened? There is a moment because of which the vehicle is going to sway around this, okay, central line of the cylinders. So this is called swaying couple, and the effect is called swaying effect. I think you are able to understand what is tractive effect, what is swaying couple, what is hammer blow. If you consider entire unbalanced force which leads to tractive effect, okay, that is Fi. Also, if you try to balance partially, okay, and attaching the mass of exactly opposite direction of the crank, okay, Cm, that is a fraction of the mass, then also there will be a unbalanced force along the line of stroke, that is C, only C times mr omega square cos theta is balanced, but remaining 1 minus C times mr omega square cos theta unbalanced, that is also leading to tractive effect. Okay, but this case C times mr omega square cos theta balanced and 1 minus C mr omega square cos theta unbalanced, this case is less effect than if you try to balance entire thing. Okay, then entire thing is going to give vertical component, that leads to hammer blow. Okay, so partial one leads to some C into mr omega square sin theta. When theta becomes 90 or 270, then it is becoming maximum mr omega square, C mr omega square. So this is leads to maximum, and this becomes hammer blow. Okay, but in inline engines, two cylinders are there, force can be balanced, but there will be a couple which remains unbalanced, that is called swaying couple. That's why it is given that F. Here I have written F1 into C by 2 plus F2 into C by 2. So that is, it becomes, if F1 equal to F2, then it becomes F. Okay, F into distance C. Okay, D, whatever I am going to say, used here, D. Okay, so this is the effect. Here in this relation, see here, this is vertical. Vertical means it is perpendicular to the line of action. MB it is written. MB, it does mean it is C times mass which is need to be attached, okay, to make it complete balance. So only partial amount of mass we are going to attach, that is MB equal to CM. Here you need to understand this point. So these are the three components, magnitude wise, expression wise we can express, depends on the condition, whether you are going to balance it, fully balanced effect and partial balance effect. If, in both the cases we have effect of tractive effort, swaying couple in case of inline two cylinder engines, and hammer blow. Okay, so swaying couple exists only, it is inline two cylinder engines. Okay, otherwise it is, there is a unbalanced force perpendicular to the line of stroke. When it becomes, its magnitude is maximum, this leads to hammer blow. Okay, you can understand based on the condition, right? Okay, then we can compare, okay, meaning of all these. Tractive effect, as you have seen, what happened? Tractive effect, physical effect, what we can see, physical effect. So tractive effect leads to along the line of stroke it is, that's why engine tends to, because unbalanced force this one, engine tends to move forward and backward irregularly, continuously, because the magnitude is also going to change. Piston is, okay, omega, this is going to change. Piston is having changing, continuous varying its velocity. Okay, because power stroke, there is some amount of force, and this compression or the expansion stroke, different amount of force. So it is continuously varying. That's why irregularly it will move forward, backward, depends on, okay, the stroke. Swaying couple, also what happened, what is the effect? Engine tends to rock sideways because it is perpendicular component to the line of action, left and right. It's also magnitude varying. Okay, it's all effect on the force on the piston. Acceleration of the piston is continuously varying, that is force, that leads to inertia force also varying. Okay, hammer blow, as you have seen, it is maximum magnitude, it becomes at theta equal to 90 or 270, then wheels hit the rail, means it is taken inline engine, rails, and in between two cylinder engine, then up and down like hammering. Okay, it is significant, its significance also written. Tractive effect, all reciprocating engines, it is very much significant to see the and control how we can make the balancing, how much maximum balancing can be done, we can do that. Entire complete balancing is not possible in case of reciprocating unbalanced forces or masses. Swaying couple, in case of multi-cylinder engines, we have seen only it is giving couple. Okay, forces will be balanced. Hammer blow on steam locomotives, it is giving continuous up and down motion like sound, hammering sound. Okay, so what is the effect on machine? These are, okay, because of tractive effect, there is a speed fluctuations. It is jerks, it will sudden movement we feel while we travel in the locomotive also. Swaying couple, side vibrations, hammer blow, rail damage or possible wheel lift also. It is very much dangerous. Okay, these are the effects of these three phenomena. Okay, so we have seen tractive effect, incomplete balancing of reciprocal masses leads to tractive effect, even though it is okay, only incomplete balancing of reciprocal masses, tractive effect. Otherwise, if you fully balance, then there is no horizontal component because inertia force is in line of stroke direction. If you fully balance, no way to talk about tractive effect. Swaying couple, of course, it is vertical component of unbalanced masses or balancing also. If you do attach the mass opposite to the crank, then vertical direction perpendicular to the line of stroke, there is a unbalance. In multi-cylinder engines, two-cylinder engines, then this swaying couple is the phenomena. It is a improper distribution of forces in different planes. And hammer blow, okay, overbalancing using rotating masses, because it is maximum magnitude. Okay, so of force in a perpendicular to the line of stroke. Okay, so what is these important three are interrelated problems. Have you seen that? Because tractive effect, horizontal unbalanced force, swaying couple in two-cylinder engines, if you talk about. Otherwise, its magnitude maximum, the force in perpendicular to the line of stroke, then it leads to at maximum magnitude, continuously it will repeats, then it is hammer blow. Okay, so this is about all these. Equation wise also you can understand. Tractive effect we have seen. Okay, it is cosine variation, cos theta, cos 2 theta terms are there. Swaying couple, okay, that force, unbalanced force in perpendicular line of stroke into distance, you have seen. Two-cylinder engines only it will happen. And in case of hammer blow, it is sin theta variation, but when theta becomes 90 or 270, it is its magnitude maximum, then this phenomena is exist. Okay, so with this, this is the final conclusion that tractive effort is horizontal unbalanced force causing forward backward motion. Swaying couple is unbalanced movement causing sideways oscillation. Hammer blow, vertical force variation due to balancing masses causing hammering on rails. Okay, it's all. So horizontal tractive, sideways swaying couple, vertical direction hammer blow. Okay, so I think you are able to understand the concept of these three phenomena. We are going to discuss more detail while we deal with some numerical exercises on these and particular cases of type of engines in our coming lectures. Okay, thank you one and all.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.